everyone. This is Vishnu, and my TikTok uh, concept is on smart round robin CPU scheduling algorithms for operating system and for our subject OS operating systems. And let's get started. So, why is CPU scheduling necessary? So, one of the most important features is multitasking, where uh, the user decides to open two or three applications or two or three copies of the same application and run and perform operations simultaneously on each and every application, then the CPU scheduling will be, I mean, it plays a very important role as it schedules what all are required, the operations that needs to be carried out. So CPU scheduling also aids in increasing an operating system's efficiency in terms of multitasking. It depends on how you schedule it, where this round robin will schedule it, um, won't schedule anything with respect to time. It will allocate a space with respect to within the basis of queue data structures, which is first in, first out. So whichever operation came first will first gets executed, and so on. So many tasks in a multitasking operator system require CPU time. So moving on. How can an operating system achieve it? So with the help of round robin scheduling approach, uh, we can achieve it, where round robin will collect all the operations in a queue, which follows first in first out operations, and uh, the operations will be sent into the processor, and before uh, sending the data for processing, there will be a quanta which will allocate amount of time that needs to be uh, take for an operation to be performed. So it's known as quanta, and then the process will start getting executed. And if it's not if the same operation occurred, then it will then get into the same array, or we can say queue. It will get added onto the queue, and when time arrives, it will start executing the process. So as you can see over here, these are the diagrams, flowchart diagrams, you can say, of both traditional, or this is a traditional round robin algorithm where the queue is empty, and if queue is null, then we need to add all the properties or all the operations that needs to be performed and arrange processor in increasing order of burst times, and calculate a modified time quantum. And uh, with in this algorithm, they're calculating if the process a percentage of 2, which is nothing but it's checking whether it's even, and then um, MTQ is getting updated by the average burst time of all the processes taken, where as you can see, it's a loop, a uh, condition where which is allowing it to perform a loop. So if MTQ is less than or equals to the burst time of the mid process, uh, won't go anywhere. The process execution will get terminated without any returns, we can say. Uh, Otherwise, the MTQ is being assigned to the processor pi. Px less than or equals to MTQ is a condition. It's not a condition because it's not in a rhombus. So or a diamond shape, you can say. So if x is less than or equals to number of the processes, then it will calculate the average waiting time, total average taken, and CS. Then it will stop by updating, by calculating and updating those values. This is a traditional way of um, round robin. So on the right side, this is a round robin CPU scheduling algorithm where um, the starting is same, where it adds the all the processes in the ready queue, and it arranges the process in increasing order of remaining time. Shortest uh, process first, SPF, it's also known as, where if a process can get executed in, let's say, once millisecond, 10 milliseconds, and the second process can take up to 30, and the third can take up to 5 milliseconds, then the third process will come first, then the first process will be second priority, and the third process will go last. So based on that, uh, the process will be arranged, and if all processes have completed execution, then it will return A, or return A, where A consists of the calculated uh, average waiting time and average turnaround time, TAT, that is. So, or else it will calculate the smart time quantum, which is nothing but the time which will be taken by a process to get executed by the processor. And if all the processors are in the cycle are traversed, in the sense, uh, if if all the processors which are there in the queue are being read or are being utilized by the processor or been processed by the processor, then it will get into the um, arrangement process, or else it will proceed further for next process. If remaining time is less than or equals to STQ plus delta, then it will run the remaining process, or else it will run the process per STQ time. And this loop continues, and at the middle uh, diamond, if all processes in the cycle are traversed, then it will get into the average time, average process, average process in increasing order or remaining time. And since all processes have completed execution, it will get into the it will return calculated average time and turnaround time. And the differences are in between is one, that shortest first uh, is not there in a classical or traditional round robin system, where shortest job will be done first. But in the smart round robin, it exists, and this is one of the main differences between these two flowcharts, we can say. So with the help of this smart round robin systems, we can say that it may take less time to process most simple operations. Like, let's say a person is copying files, and the same person wants to copy or paste or rename a file, then renaming the file will take less time compared to the copying of the file. So first this will be get executed, the renaming of the file, and then it will take care of transferring files from one place to another place, whereas the traditional one uh, will wait for the process execution or the file transfer, then it will allocate space and processor for renaming the file. So this is what all about the smart round robin system. Thank you.